Welcome to Gunship.
Hello everyone, my name is Andy. I'm going to talk about continuous integration, that is CI for Haxe projects. So this is my profile on GitHub. I've been working on a lot of different areas like mobile user interface design, interactive installations, augmented reality apps. And however, in this year, I've been trying to contribute to the main Haxe repo more often than writing third-party libraries. And then, however, well, I do have quite a lot of different libraries like jQuery externs, HX car toolkit, HX serial, HX UDP, to name a few. And then, yeah. So it's really my pleasure to attend WWX, and which I've wanted to attend for many years, but I just didn't make it because, well, here is France WWX, and I've been living in the tiny corner there. And not to mention, well, actually Hong Kong has the highest living expense worldwide. And I have just defended my PhD thesis, and I don't have a job right now. So, well, it's really expensive for me to travel to here. But, well, I think it's totally worth the cost to meet you here in person to talk about what I think is the most valuable and effective way to maintain a stable code base. So what exactly I want to talk about are those. Well, the adapter isn't really stable, probably because, well, we cannot set up continuous integration for those adapters. Come on. Oh, cool. Yeah. Yeah. So, yeah, what I want to talk about are those badges under the repos README file, those green badges. And what they are telling us are the continuous integration status of that repo. For example, well, if it's green, then everything is okay. If it turns red, then, well, something is broken, and, well, just cry and then, well, fix the problem. And then, so in this talk, I will tell you why every programmer should get those badges, and then, well, how to get them. So what is the exact definition of continuous integration? So what is it? Actually, CI is a development strategy in which programmers continuously try to commit codes into the baseline branch, which usually is named the master branch. In the opposite of CI is like using feature branch, which, well, when you develop a feature for your project, you branch from the main, the master branch, and then you develop something, and then when it is complete, you merge it back to master. And in the meantime, if you want to work on other features, you branch a lot of different branches for each of the feature you developed. And then the problem is when you want to merge all the feature branches to the master branch, well, it's very often you get merge conflict, which is, well, troublesome to deal with. So CI try to avoid that by, well, just when you develop anything, you try to commit onto the master branch as soon as possible, and then, yeah, such that, well, because there was just one branch, then there will be low merge conflict. But of course, the problem of that is that, well, the master branch will evolve so quickly and rapidly, and then it's hard to make sure that everything you commit is stable and you won't break anything. So people find that the key to CI is to maintain the master branch in a fully functional state. Is to use a build server to try to trigger automatically build and then unit testing of your code for every commit when you commit onto, well, the master branch. Such that, well, if anything is broken, we will be notified by the build server. So let's take a look at the branches one by one. The first one is Travis CI. Actually, all of the, well, those batches are free for open source projects, so, well, good stuff. And the first one is Travis CI, and then just clicking on the batch will take us to the build result page of the Haxe repo. So this is the build result of a commit, and unfortunately, this particular commit has failed. And anyway, scoring it down a little bit to see the whole build matrix. This is what we call a build matrix, which is for each commit we launch a list of different individual builds for that commit, and then we just configured it to test both Linux and Mac. And then for each of the operating system, we launch our individual build to test a target. So we test, for example, the CPP target in one build, and then we test JavaScript target in another build, and then they will go testing in parallels. As a result, we can easily spot which target is failing. For this instance, the JavaScript target is failed, and the Flash 9 target on Mac has errored. Clicking on any of the build, any of the row there will bring us the build log of that particular build, and then again scroll down a little bit, and we will find those commands we are running inside the build. For example, well, of course we have to install OCaml to build Haxe, and then we will build the compiler, and then finally we run the test suite by running some command. And then, well, Travis CI covered Linux and Mac, as I have mentioned, but sadly, it does not provide Windows for us, so we have to use another CI service, which is bring us to the second batch, which is FRAIR. And then again, clicking on that batch will bring us to the build result of the current commit. And then it's kind of similar to Travis CI. Well, we also have a build matrix, although it's much smaller. For the first build, we test, well, Nichols, C#, Java, macro, and then for another build, we test C++ target. The reason to do that is that, well, the free pan of FRAIR is, well, provide a really slow machine. So it takes a lot of time to run the unit test, and then, well, we just try to combine them to save time, to save the unit testing time. And then the free pan do not provide parallel builds, so those two builds are executed in sequence. Well, anyway. And here is the build log of the first build. Again, we will find some commands we are running in that build. For example, again, well, install OCaml, and then build the Haxe compiler and run tests. Finally, the third one is Silex Labs. It's not really technically a CI service, but it's provide automated testing for browsers. So we covered the desktop targets like Windows, Mac, Linux for Traffic CI and App Layer, and then finally we use this Silex Labs stuff to test all kind of browsers like this. For example, for the Haxe repo, we test the Android stock browser. We test on the Firefox, Chrome, IE 8, IE 9, IE 10, IE 11. We test for iPhone stock browser, and then we test for Safari. And then really seriously, it would be really hard for us to test that many browsers without automated service. I don't know, it's common for me to change a few lines of code in like 10 minutes, and then I will spend like half an hour to test all those browsers by hand manually if I, don't use a service like this. And actually, not just for commits, and the CI builds are also triggered by pull requests. So that is, it will check if any test will fail if a pull request is merged, since they notice those tiny text and clauses next to the title of the pull request, which tell us the build results. And then if we enter the page of the pull request, you can see that there are individual build results of our CI service. And if any of them failed, we will notify it, so we won't click on the merge button before the pull requester has fixed them. And I think it's extra helpful for open source project because it's troublesome to merge and check everything manually in your local machine. Normally, we just take a brief look at the code diff, and then if everything looks all right, we will just merge, and then it provides an extra layer for safety to check that our test will pass after merging the pull request. So this is a short summary of the 3 CI service providers. By using them, we test our code across Linux, Mac, and then with a dozen web browsers. And then and they aren't cheap; they are actually just free. And then they are all cool enough to provide service to open source project. And there exists CI service provider that also provide free service for private projects. But you just have to look around up the internet. I will just talk about this. And it's really clear to us that, CI is helpful, and by letting us discover cross-target issues and regression by automatically run tests on the build server. If every Haxe library over start to use CI to give some promise to user that newer version would never break the user's code, then we will possibly to say goodbye to the nervous feeling that every time we decide to upgrade our Haxe libraries, worrying that the project will be, will no longer compile or, fail at one time. So it sounds useful, and however, I know what you are thinking. I believe that it is always possible to write tests for any kind of projects, but I know that is somewhat troublesome and difficult in some cases. For example, when you are developing a GUI application, it's hard to write automated unit testing for user interface. And then, when you are when you are building a game in a game jam, you certainly won't write unit tests for your game because, you are just experimenting with your game mechanics and stuff. And I totally understand, that's fine. However, what if I told you you can still use CI without writing tests? And That's true. In fact, there is always something suitable to be run on the CI server. And guess what? It's the Haxe compiler. You can, Haxe is a compiler language. You always have to launch the compiler to compile your code. And then it's a statically typed language. It catches a lot of errors by just type checking during compilation, and it catches a lot of error and typos. And then secondly, we definitely want to keep our project maintaining in a compilable status. I cannot think of in what status you can, let your project doesn't compile. And thirdly, we have loaded, the compiler is powerful enough to detect a lot of error for us. And then there's a real benefit of using a statically typed language. And we have macros to help us to write even more strictly typed code to detect more errors for us. So let's just run the Haxe compiler in our CI build first, and then at a later stage, when you think that, it's not enough, you really need tests, you can always add more tests to be run on the CI server. So how to set it up? I will do it in, I think 10 minutes, 10 minutes, not 5 minutes. But, let's mirror the display again. Yeah. So I've already prepared a Hello World project. This is just, as I said, in Hello World. So we have a main class. There's a single trace statement there, Hello World Wide Haxe. And then we build it with a build.h6ml. We just target Nickel because, simpler. And then we run it with the -cmd Nickel main.end. So let's try to run it. Oops, forgot to do so. Sorry. So pretty simple stuff. Launch it. Yeah, it works. Great. That's a Hello World project. And then where is the browser? I have exited my browser. Yeah, full screen. Silly me. So I've already committed the current status onto GitHub. Nothing complex, nothing tricky. And then what I'm going to do is to set up Travis first. To tell Travis how to run our code, we have to provide the configuration file as .travis.yml. So in fact, we have built-in support of using for the Haxe language. You just type language Haxe, and then we can select different version of Haxe. Like, we may want to test it for 3.2.0. Let's see if it works on like 3.1.3. And then let's test one more. Let's test for the development branch of Haxe. See this hardware program will work a lot. So we specified the version of Haxe we want to use. So this will take care of the installation part of the build. And then later we have to install Haxe Lab dependency if we want to use, for example, target CPP, then we have to Haxe Lab install HXCPP, but we are just, using the Nickel target, so just leave it. Finally, we have to tell it how to test our code. Oops, I don't think it's test, I think it's a script. You see? Well, anyway. Just to type the usual command, how to build the program, well, has build.html, and then save it. Looks correct. Yes, it looks correct to me. And then let's try to commit it to the repo. Before doing that, we have to go to Traffic CI to turn a switch on such that it will really monitor our GitHub repos for any new commits. So we just head to Traffic CI, and then there was tiny buttons there. Oops. The plus size. And then we have to click the sync button because, well, I've just set the repo up a few hours ago. Yeah, after we sync it, we should be able to find the repo here. We just turn the switch on. Okay. And then let's commit the configuration file. And then, oops. And then the URL will be trafficci.org, and then my GitHub username, and then the repo's name. If we go to there, we will see that, well, actually the builds are already running. Let's take a look there. Well, there are a lot of messages coming out there. Basically, traffic is really high performance that the build often finishes in within a minute. Okay. It installed netcode, and then it installed Haxe, and then it tells us the version we are testing for this particular build is 3.2.0, okay. And then the netcode version, and then finally the test command we specified in the traffic.yml file. And then we can see the hello world statement print out in the log. And then, yeah, there are 3 different builds because we specified 3 different versions to test for. And then, I don't know, well, whether you test your library with different versions of Haxe. I sometimes do so on my machine, but, well, usually I just depends on Travis to test it for me. So the next one is Everywhere, and then it's kind of similar to Travis, and what we do is just to, well, have another configuration file. This time it's called everywhere.yml, and then the configuration is again very similar, but I do not quite remember that. So let's just copy and paste that, and of course, we don't need that many commands. For example, let's see. Let's try to install Haxe version 3.2.0. We use Chocolatey, which is a package manager on Windows. Anyway, you just install Haxe, and then we will set up Haxe lib, and then install some libraries, but we do not really depend on any libraries, so take it out. And then there are two different stages which are different than Traffic CI. In Traffic CI, we have install and then script session. In Everywhere, they call it install, and then they have a build session, and then they have a test session. But we just do everything in the test session, so we tell it to, well, just do nothing for the build session. So what we do is to run has.build.html. Basically, yeah, that's it. That looks correct to me. And then again, we have to go to app layer to activate that project. Well, what we do is again, well, go to new project, takes a moment, and then find our repos. It's here. Click add, and then push the commit, the configuration file to our to GitHub. Commit. And then, yeah, you can see that, well, there is a new build that has been queued in the, well, build queues of AppWare, but, well, usually it just takes quite a long time to have that start comparing to Traffic CI, and let's just leave it here and wait for it after I finish, well, the rest of the slides. So what we have done is that we set up a Haxe project. Well, I've already done it for you, and then create a new repo on GitHub, and then just turn on the switches on Traffic CI and AppWare, and then just copy and modify those configuration files for your own needs. You can do whatever you want to do, because that is running in a fully virtualized environment. You can even use sudo, apt-get, whatever you want to use. And then finally, when you have the configuration file ready, you just commit and push to GitHub, and then, well, you can add the badges to the README to showcase that, well, your library is fully tested, it's solid, and yeah, it will be great. Things I didn't cover is that I didn't cover Source Labs. Source Labs is a little bit troublesome to configure. You can look it up on the links I provided here. I will, well, of course, publish it on the internet later. And then you can write proper tests for your libraries. There are quite a few good unit testing frameworks out there that you can try to use. And then there are some other interesting ideas that you can do in the build server. For example, well, you may want to upload your library to Haxe Lab for every release tag you push to GitHub. And I've tried it. I have an example working for one of my library. And then you can try to enforce coding style using a chat style library. I didn't try it. I haven't tried it yet, but well, seems easy to do if you are really into tabs versus spaces or where to place the brackets. You can enforce that in the build, in the automatic builds. And then finally, you can check README files for spelling mistakes. You can do that for documentation or other stuff. Maybe with ASPL, which is open source library to check spelling mistakes. And there are some more libraries for that. I haven't really used that, but yeah, sounds interesting to use. And basically, that's it. And if you have any question, please ask me now. Thank you.
So I didn't really catch what Source Labs is that for some kind of end-to-end testing, or what is it point and click end-to-end testing, or?
Some more detail on Source Lab testing is just they provide an API that if you use some the Source Lab provided drivers, it can drive the test to deliver some web page to the remote remote browser of Source Labs, and it will try to open your web page and then return. You can query the results of your test from like the console or some HTML text on the web page. You can query that, and then that API do not give you a workable environment to really build your Haxe source code. So you have to drive that within like Traffic CI. Yeah.
So it's scripted. You script interaction with it, or?
You're asking the interaction between like the web page and.
Yeah, because the other Travis and like that, they run unit tests, but there is no point. I mean, you don't run the unit tests in different browsers. You interact with the product, or.
Yeah, okay, I see. They have an API for you to interact with the web page, like clicking on elements or to query whether some elements is visible on the inside the browser or not, or you can send some JavaScript to be executed inside the Source Lab browsers.
Oh.
Yeah. Yeah. Yes.
So I just want to put what he did in perspective, because 2 years ago we were in the stone age of testing, and it pretty much relied on me running the unit tests locally, and it was just a mess. And then he arrived like descending from the sky saying, let's set up Travis. And we were like, okay, what's Travis? He basically told me to just click some button and he would handle the rest, and that's how it went in the end. And it's such a huge difference now that...
Thank you. Well, to be fair, I just set it up. I just set up the configuration file. All the technical stuff are set up by Travis and everywhere, and yeah, they are just doing amazing jobs. And that's interesting that we know that there exists CI solution, but however, a lot of us didn't really check it out, and actually I have just shown you that it's just a matter of clicking some buttons and give you all the commands and give them all the commands, and they will do the jobs for us. And yeah, it's easier than registering a GitHub account, I think.
Hi, I just wanted to ask, if you've got a base library and you have other libraries that use it, and you want to make sure that the other libraries that use it still work when you've changed the base library?
Haha, this is an interesting question, and I'm still thinking about that. The current status is that, you will only know that, whether the test failed or not, and it's your responsibility to look at the build logs and see whether it's your fault or some other people's fault. But anyway, first of all, you can specify the library version you use when you install the library inside the build server. You just type haslib install like OpenFL or 3 point something, or I don't know. I don't use OpenFL nowadays. Yeah. First of all, you can specify the version such that you know that that version will work for you. Another thing is that even if you don't specify the version, when a new version comes out and then it broke your program, then that's actually a good news. Then you know that, the guy is doing something bad, and then you can notify them, you broke your API, and I'm really depending on your API, and please fix that. And that's a good thing, I think. Yeah.
So you can't chain them? Chain one Travis to call another one?
Yeah. I also have thought about that. For example, is like, for example, for the Haxe repo, for every commit, after the build has finished, maybe we can use some Travis CI API to trigger some other third-party libraries Travis build and see if that it will break their libraries or something. Yeah, we have thought about that, but we just haven't really touched the Travis API yet. Yes, and I've heard that Travis have thought about to have this chaining functionality built into their service, but they didn't really implement that yet. And then some other people tried to do that, and I will have to look at how they do it and will implement it for Haxe. Yeah.
Okay, first of all, if you want to come to the conference for free, please apply at Gamewell. I'm kidding.
That would be great.
Okay. Okay, at Gamewell we have kind of a problem that we need to test with a graphical environment. So basically we want to run unit tests on the games, and they have to be running with a graphical environment, so OpenGL has to work, etc. We have set up kind of a machine and a Jenkins slave in a weird way that kind of allows that, but I'm not sure if either Travis or FAR have some solution for that.
No, they don't have any specific framework or libraries for help you to test codes graphically. I saw people use some open source stuff to do that. I cannot remember the name of that right now, but I don't know. I have used those kind of visual testing stuff myself, but it's always been tedious for me to set that up. And then what I would suggest is just to, well, unit test your individual functions one by one instead of doing that visually. I don't know.
There is one thing. The name is really weird. It's like XVFB. It's like a virtual frame buffer.
Yes. That thing. Well, actually, you do have a virtual screen inside Travis CI and every year. Yes, you can launch your OpenFL game inside that. You just cannot, well, visually see the screenshots of it.
Yeah, I don't need to see it. I just need to somehow run. And
yeah, you can run it. Yeah, it supports OpenGL, I think. Yeah.
It's also interesting, I guess, for testing like interaction with the app, like clicking buttons and stuff. So.
Yeah. One approach I have thought of is just try to launch your game like for 10 seconds, and then you queue it after 10 seconds, and then if there is no error, then that's fine. Or else maybe it will error because it's missing an NDLL or missing some dependency.
Semicolon.
Yes, semicolon. That will be catched by the compilation status. Yeah. That's compiler will be helpful.
Thank you.
I sent the pull request for the library we just set up.
Okay.
You should check your pull requests on the WWX 2015 library.
Oh, really? You have just made a pull request? I've told you, well, this is just a demo. Look at another repo. Why you don't hear my words? Okay. Any other question? Oh, it's failed.
That's what it looks like when the build fails. I'm in trouble.
Okay. Okay, the FAR build has passed, luckily. Yeah, that's it. Well, we should set up CI for hardware sometimes.
Welcome to Gunship.